Hello and welcome. The topic of this video is about the important visual cues in data visualization. It's highly recommend everyone to watch this wonderful video from Professor Hans Rosling on data visualization. Rosling's work was one of the drivers for the explosion of interest in data visualization. It sparked a huge interest in storytelling with data. You may find the links provided below. Here is another version for the previous video, but allow you to play more interactively. Let's try to play a demo here. So, you may just play what Professor Hans Rosling did, or instead of displaying 200 countries, you may choose a few countries that we are more interested. Let's pick a few countries let's pick a country like China. Okay, we may pick a country like Japan. Let's pick an African country, South Africa. So we may only pick 3 countries that we are interested. And instead of saying 200 countries, you may pay attention to just the 3 countries you have picked. And interesting, you may trace those fewer countries' trajectory paths over years. So the specific path plot will be given to you for the 3 countries. Well, the huge size one is China. Well, you have seen that China has been stacking around for a long time in the lower part until 1980s it started to increase. Okay, and how about Japan? Japan is increasing quite fast even after the first industrial revolution, so much earlier than China. The smallest one is the South Africa. It was quite stable and developed fast after the Second World War. So, what are the secrets behind this visualization? We all want to create such a high quality of visualization plot, right? Let's look at a screenshot here. What information you can get? You see the life expectancy, you see the income, you also see the population size, right? You see the colors, which are the different regions of the world. What else have you seen? The time, the year, right? 2007. So this is a static plot for this Hans Rosling's visualization. Now, let's practice a small quiz here. In Hans Rosling's visualization plot, can you tell how is the data being displayed? Or more specifically, how can we transform the various data variables into the distinctable display elements? Let's start from the life expectancy data and the income per person, total population, world regions, and the last one is time. So how are those data variables displayed in the visualization? Let's start with the life expectancy data. How is it displayed? It's actually in the y-axis, right? How about the income per person? It's the x-axis. And the population is the size of the circle. You see China, India have much larger size. The world regions, that is in the different colors, right? The last one is the time. It is shown as a text message in the middle. All of those display elements are classified as visual cues. So next, we will introduce you the various visual cues. There are 8 components of visual cues. The first one is position. Like the scatter plot, you have position X and position Y. The second is the length, which is often used in a bar chart. A higher bar chart means a larger value. The third is the angle. like in a pie chart. We also have directions, the shape, like a star, square, or a circle. The rest are the area, size, and color. Let's examine a few of them. So for position, that defines where in space or coordinate system the data is. For example, in this x and y coordinate system, so we can easily display two data variables, the x and y. Can we have three data variables in the coordinate system? See, we have x, y, and z, the three-dimensional plot. Look at this plot. Does it work properly? Not really, right? We can hardly differentiate the two data points. Not everyone can adjust themselves to a 3D figures. So this is not a good practice to have 3D plots. Then, how can we display more data variables in one plot? We may try other data visual cues. For example, the length and size. For length or size can be the third-dimensional data variable. Remember in the Hans Rosling 200 countries, 200 years, size means the population scale. As for angle, ranges from 0 to 360 degrees on a circle. It is often used in a pie chart, means the overall percentage of each category comparing to the whole, for example, like the market share. As for directions, it relies on a single vector's orientation in a coordinate system. So you may observe which way is up, down, left, right, or in between. As for the shape, you may use to differentiate categories and objects. Here are some distinctive shapes we often use. The visual cues, color is one of the mostly used. Well, even for colors, you may choose different formats, like the following format we show below. One is with different color, the red, blue, orange, yellow. The other you may have a different scale or saturation, like the dark green, green, the light green, and etc. Here are some retina variables you may use to display your data variables. They all have different visual impact. After learning the various visual cues, it's time for us to apply the visual cues design principle. Let me introduce the importance ranking for visual cues. It depends on the accuracy of graphical perception. So if we list those primary visual cues in terms of its visual accuracy from the more accurate to the less accurate, you will find those mappings here. Generally speaking, you would display the most important data variables using the more accurate visual cues, like the position, the length. For less important data variables, you may choose the less accurate visual cues, like the color and the size. Finally, a small exercise for you. Can you rank the importance of data variables below? The most important data variables is about the story we want to convey, right? Should be the income and the life expectancy. So we use the X and Y position to display. As for the rest, we use the size, the color, and the text. Thanks for watching and enjoy your learning.